All right. Hello, everyone. This is the Zcash Arborist call, and I'm Aditya from Nighthawk Apps. I'll be hosting the call today. Let's go over the agenda. We have a welcome and meeting intro, followed by the ZF Zebra updates and ECC core updates. Then we'll have time for research and implementation status updates, open discussions, and then a wrap up and announcements, and any other comments we might have from the attendees. What are the Arborist calls? They are the bi-weekly calls where Zcash protocol contributors convene to discuss upgrade timelines and process, protocol R&D efforts, design, and implementation of new protocol features, and identify blockers and unresolved issues. And the purpose of this is to make the core Zcash protocol development accessible for a wider set of participants and provide more transparency for the community at large. Who can participate? Any member from the public interested in learning about Zcash protocol development can register. If you want to present an in-depth agenda item relevant to the Zcash protocol, feel free to contact Ian at the email listed on the screen and request a presentation slot. Other ways to get involved are the Zcash Community Grants Program, the Filecoin and ECC Grant Program, and the Zcash R&D Discord for communication with the community. All right, let's get started with the Zebra updates. I believe we have Pili from the Zcash Foundation on the call.
Yes. Hi, everyone. I'm Pili. I'm the engineering manager at the Zcash Foundation. And I wanted to give you an update of where we are with Zebra today. So I think since the last Arborist call, we've been very busy. We've been manually testing Zebra on testnet because we wanted to make sure that we could use Zebra to mine a block there. And we've managed to mine a number of blocks using a modified version of SDOM and also CPU miner. So we've got a set of instructions that we want to publish of how we did it, and so others can try it out if they want. So before we ask mining pools or other people interested to try it out on mainnet, we want to implement a few more methods that we think some people might need. I mean, we've been working with SNOM because it's open source, and that's what we could use, but we still had to modify it a little bit. This is out of date. So once we implement the remaining RPC methods, a few performance improvements, we want to, we'll be looking for volunteers to test it out and provide feedback. So please reach out to us on Discord. I mean, there's always some of us on the Zcash R&D Discord, the Zcash Foundation, or the Zcash community Discord servers. Other than that, we tagged our 5th release candidate, which is Zebra 1.0.0.-RC4. And we're looking to tag another one soon. So probably once we finish implementing the remaining RPC methods and some performance improvements for mining pools, we will release RC.5. So please keep an eye out for that. And if you want to test out mining. And I think that's all for Zebra for today.
Excellent. Thank you, Pili. Anyone else from the Zebra team wants to share any updates? Okay, we have Dara who wants to join as a panelist. I'll promote Dara. Okay, then let's move on to ECC core updates. Who do we have from ECC?
I can give a summary of what we've been doing. So yesterday we tagged Zcashd 540. So new release of Zcashd.
Your microphone is a little bit low.
Okay, I've got it. I think I've got it. Let me check my settings quickly. Is that better?
Yes.
Okay.
Thank you.
So as I was saying, yesterday we tagged Zcashd 540. There are a number of changes in this release. One of the ones so we've had a number of comments from the community asking for accurate supply numbers. And so the Get Blockchain Info RPC call now on nodes that have been re-indexed with this release will have information about the size of the total supply and the transparent pool. There are a couple of bug fixes that have been reported from about 5.0.0 on that are now in. We've backported a number of changes to the for miners to the get block template functions from upstream. That's in preparation for ZIP 317 implementation, which we're working on now that we expect to be in the next release for ZIP 317 rules to be used in block selection. A couple more things that will be of interest to people who are using Zcashd. A number of the previously deprecated features are now disabled by default. So the get new address, get raw change address, Z get new address, and Z list addresses. Those are the most commonly used RPC methods that have been deprecated in favor of the new account-based operations for getting new addresses. So since we implemented mnemonic seed derivation derivation, HD derivation in Zcashd in 4.7.0, we've been encouraging folks to move to the new methods that do regular derivation from that mnemonic seed, or it's defined as in ZIP 32, I believe. So the old RPC methods, while still supported for a little while longer, if you need to use those, it's possible to set the allow deprecated flag to allow particular previously deprecated features to be used, but those will be going away, so we encourage you to migrate off of them. So anyway, a lot of that is sort of preparatory work. Zcashd 5.0 we're working on heavily right now. That's going to be primarily ZIP 317 support, both on the wallet side and on the block template construction side. So I think that's most of it. Dara, do you have anything else that we should talk about?
Did you talk about the bug fixes to reindexing?
Oh, so there are a couple of long-standing issues where it was not possible in some cases to shut down a node during reindexing because essentially if you hit Control-C during a reindex or a rescan, the node might not find an interruption point, and both of those have been fixed so that you can now shut down a node while it's reindexing and have it start back up without having it run a long time before it halts from the Control-C. So that should help in the case that that you need to start a reindex because you want the supply and transparent pool numbers, and then need to shut your node down. So it is not required to reindex a new node starting with 5.4.0, but if you want those transparent pool and supply numbers available in your Get Blockchain Info call, then you'll need to reindex.
And did you mention to fix the Orchard wallet? I can't remember whether you did.
Yes, that was the fix that I mentioned. So yeah, the Orchard wallet had a bug where it could throw an assertion failure in the case of usually in the case of a combination of reindex and rescan that has now been fixed. It was not a potential loss of funds bug. It was just a consistency bug where you would have to essentially start a rescan over in the case that or you would have to rescan the wallet rather than simply reindexing.
Yeah, that's everything. I think
there's one other thing, which is that
sorry.
there's a known issue with the release, which was identified, like we were already 4 RCs in, so we decided to just get this release out. That is, when you do reindex on some systems, your RPC interface may lock up for the duration of the reindex. It will it's a locking issue internally, lock thrashing exhaustion. We fixed it in master, so if you if that is an issue for you while reindexing and you wish to reindex for this, then there's nothing currently merged into master that would, I think, be a problem. Otherwise, just hold off reindexing until 550, which will include the fix, or the next release, whenever the next release is.
The reindexes generally take upwards of 24 hours, and the locking issue may extend that by 8 to 12 hours, I think.
Yeah, because it also causes the wallet internally to get delayed behind the main reconnecting thread in terms of its notification, like where it's been notified of the reindex up to. But yeah, we haven't seen it on. I don't think we've seen it on every system, and the Control C still works. So even if the RPC is locked up and you can't stop the node that way, and you need to, you can, like the Control C fixes that we deployed do work now for this.
Okay, sounds good. Thank you for all the updates and the bug fixes being shipped. I guess we have one more slide here. Do you want to go over this?
Oh, that was the slide that probably should have been up while we were talking.
I see.
Although,
yeah, that would have reminded me of everything. Hang on.
Oh, yep. There've been a few.
little bit out of date.
Yep, there have been a number of changes in Libra Zcash. That second bullet point is the important one. That Strad has done a bunch of refactoring of the sapling module to bring it closer in API to the Orchard module, and the goal there is that we want them to have essentially the same interface and update the transaction construction code in Libra Zcash to unblock the Zingo Labs from their Orchard work.
Yeah, and related to that, actually, which is also something that isn't in 540, but will be in the next release. We're retroactively enabling deploy zip to 16, which was the changes to do with the issue with non-canonical supporting parsing certain non-canonical jub points, all small order points. So for most of the protocol it was fine, but there were a few cases where it was possible to expect to be able to parse something, and now the Rust code had long been updated to essentially not do this. Zcashd will now also just prohibit those points, because we've confirmed that the entire chain prior to NU5 isn't affected by those. The effect, however,
more precisely, the entire testnet chain and mainnet chain.
Yeah. However, this does mean that if any of those cases occurred in a note sent to a wallet that Zcashd is parsing, those notes will now no longer be decryptable. But the value in those notes wouldn't have been spendable in any case, I believe, due to it essentially means that you have a PKD of 0 which means that
I checked the circuit. They technically were spendable, but you would never have generated those keys.
Okay.
The spec said to reject IVK equals 0.
Yeah. And so anyone who was deriving keys using the and deriving addresses using the zip32 style derivation or zip316 for the newer stuff would not have this problem at all. And it wouldn't be possible for someone to send you funds by mutating your address to use a non-canonical encoding this way, in a way that you could still decrypt and successfully verify. Because you would have had to have derived your address in a way that generated a PKD with this value. It's not possible for a sender to do so and cause you to see it as a valid note. So the impact of this should be non-existent. If anyone does encounter a problem as a result of this, with a reindex, please let us know. But I'm hoping that we never hear from any such person, because it should be essentially negligible to non-existent issue. The main concern had really just been the consensus rules, because that was something that, because it was sender controlled, the senders could have generated notes that violated this that we would have had to accept under consensus. Fortunately, no one did.
Good to note those edge cases.
Nate?
Oh, yeah, I was wondering, so it sounds like it should have never happened, but you said if anyone notices it, let you know. What would be an expected symptom? Like, how would you know?
Well, the symptom would be that a note that your wallet was previously aware of, it became unaware of because it couldn't trial decrypt it. So it's hard to say precisely how people would see it, because it should not happen. But yeah, essentially the behavior would be your wallet previously was able to decrypt this output and now it can't. And the way that Zcashd works, we always trial decrypt things on the fly when we spend. We don't store the notes unencrypted in it. We just decrypt them. We store them in the transactions they came in. So if for some reason someone had one of these notes in their wallet and it had not been spent yet, then when their wallet tried to select it, it would fail, because it would fail to trial decrypt at the time of trying to select the note.
And do we know of a recourse of when someone runs into the issue? Is that a fix expected in the 5.5.0 version?
There is no intended fix if someone were to run into that. If someone who encounters that is outside the defined protocol, and there is if someone ever ran into this problem, come and talk to us, and we will. I would want to investigate it basically to figure out what's going on. But this issue should never impact anyone, because it should never impact anyone who was working within the bounds of the protocol anyway and deriving keys via the method defined in the protocol spec.
Sounds good. Okay, moving on. Do we have research and implementation status updates? Is this the time we go over with Gerrit? Maybe someone from Gerrit. Oh, Deirdre.
We're gonna have. Oh, sorry.
Yeah.
Can I? I'll give a quick Frost update. We've and Frost at its heart is a signature scheme. So we've been doing a lot of deduplication of various implementations of Frost across our Frost, Red Jub, Red DSA, and Zebra libraries. So in the latest release candidate of Zebra, we have removed an implementation of Red Palace on Frost, because we had just ported Red Jub, which had an old implementation of Frost, to Red Palace and carried the Frost implementation with it. But now we are pointing at Red DSA, which has been updated to 0.40, and that's on crates.io for anyone who wants to use it. That has the implementations of Red Jub and Red Palace, and no Frost for now. We're finishing up our PR that will be basing the implementation of Frost for Red Jub and Red Palace in the Red DSA crate on our fully up-to-date implementation of Frost based on the spec and the re-randomized variant that is undergoing edits with the zip editors. So you have new Red Jub crate as well, which is 0.60 that no longer has it. That is basically a thin shell around Red DSA now to help migrate away from existing use of Red Jub, which has been a long-lived crate. And I think we're just consolidating around the Red DSA crate as having both Red Palace, Red DSA, and the re-randomized variants of Frost supporting both of those ways to do those signatures that Zcash depends on. We've also merged updates to do an aggregation optimization to the underlying Frost crate that these things depend on, which makes it so that when you are actually doing the final step of Frost, where you're aggregating all the shares together, instead of checking all the shares before you aggregate, which is you have to do a bunch of, elliptic curve math to do that check, you create the signature, and if it verifies with the group key, then you're done. But if it doesn't verify, you know that someone cheated, and you can do the one by one verify to figure out who cheated. But in the golden path, no one cheats because they don't want to make a bad signature that won't verify. And so it saves you a lot of computation at the final step of creating a Frost signature if everyone is honest. But we will catch you if you're not honest. But if everyone is, you get a cheaper to compute signature. So that got merged into Frost. So that will be available to all implementations of Frost that we have, not just Red Jub and Red Palace, all the other Cypher suites for the IETF draft. And I'm probably missing some other stuff, but that's a lot of the stuff we've been cranking on in sort of the Frost and Frost adjacent land. Any questions?
No hands up yet, but thank you for the update and all the excellent work with the Frost crates.
Oh, we have a new person at the foundation. We have Natalie, who merged in her first code change to the Frost library this past week. So welcome to Natalie.
Welcome.
Okay, if we can move to the next item then. John, do you want to go now?
So yeah, I think I can give the ZSA update. So the main highlight that we wanted to point out was that we now have the transfer implementation pull request that's out now. It's this corresponds to milestone 5 of the ZSA project. And it's, I think it can be found as pull request 372 on Orchard. And there are also a couple of other pull requests on Libra Zcash and on Zcash test vectors. We've also had like some preliminary discussions on backporting the encryption changes that are on Libra Zcash into from the ZSA project into the Orchard protocol ahead of the entire ZSA update. This is so that the internal changes that are there in the backend can be slowly merged in quicker, into the main repo, without there suddenly being a huge amount of code to bring in. So yeah, and we've also, I guess, begun more regular meetings with the zip editors and the people at Zcash Foundation and DCC. And I think with respect to the zips, that's helping us get to a consensus on the design faster. So yeah, thanks for that.
Thank you, Vivek. I have a quick question. So I noticed there the Discord comment about some signature scheme change. Is that still an issue, or is it resolved?
I think Dara responded, and I think that is generally fine. I'm still making the changes in the zips to update what Dara said, but I think that seems okay.
Dara, do you have any comments?
No, I think that was pretty straightforward. It's just a domain separation of the base point for the signature scheme.
Okay. Any other implementation or research updates? If not, let's move on to the open discussion. Does anyone have items for open discussion? Feel free to raise your hands. Yes.
Oh, for the in the Zcashd updates, I forgot to mention the work I'm doing on implementing ZIP 317 for the block construction algorithm. So that's making good progress.
Yeah, there's some slight changes that Zcashd has to make relative to 317 to account for the fact that we allow in the mempool chains of zero-conf transparent transactions, because that's the behavior that Bitcoin Core has. And so it's possible via the current algorithm, blocks creation algorithm in 317, that you can select a transaction that then isn't able to go in the block yet because its parent hasn't been selected. But that's some minor modifications in terms of just like essentially caching them and deferring them until you've either selected the parent or you don't, and so you don't select the child.
Yeah, we'll probably add a note to ZIP 317 on how to do that.
Yeah, but like my belief is it doesn't affect Zebra because you don't cache zero-conf chains of transactions in the mempool.
That's correct.
Yeah.
I see Nate's hand is up. Nate?
Yeah, this should have gone on the research updates, but it's basically there's no updates for proof of stake research on from the ECC team right now, but we would like to get a straw proposal or a sketch proposal out like within the first half of this year to get feedback on that proposal, which would be like a proposed transition plan. So that's our thinking now, but right now, me and all of the engineers are busy with focusing on like wallet performance. So that's kind of the same update as I gave previously.
Thank you. Deidre has a
Related to proof of stake stuff, the foundation hosted a community call yesterday with Christopher Goes, who works on Tendermint and Cosmos ecosystem, which was really great. And we got to ask him a lot of questions about the different mechanisms that things like Tendermint and Cosmos can provide, and how we can use their consensus layer, BFT consensus layer, and or their staking systems to use with validators that stake to help verify blocks and things like that. It was recorded and it should be up on YouTube. And it was a very informative talk, especially for me. There may be mechanisms that come with that ecosystem that make it even easier to conduct Frost signing, definitely Frost signing, and possibly also Frost distributed keygen, which is slightly harder. You don't need to do distributed keygen, you can do trusted keygen, but the Frost signing seems to come, quote, for free with some of the authenticated channels that the Tendermint and Cosmos provide, which is very attractive. So that was a great call. You can check it out. I think it was awesome.
That is awesome, and I totally missed it. And I'm really excited that, yeah, there's more discussion going on around proof of stake. Yeah, so I'll go check it out.
Yes, we look forward for the link and publishing of that call. I do have a question for Strad regarding the comment about the mempool and the chain of transactions. do we know of a mempool limit in size for Zcash nodes? Do we have a hard limit?
Yeah, that's unrelated to the fact that Zcashd does stores these zeroconf chains. The zeroconf chain thing is just its behavior from Bitcoin, which just means you can choose to spend funds that have not been mined yet, because you're able to do that. Which is impossible for shielded funds, because you can't mine something that you can't spend something that doesn't exist in the commitment tree, and things only enter the commitment tree through mining. But separately from that, yes, there is mempool limiting. It's described in ZIP 401, I believe. Is where our limiting is described. Yeah, essentially the approach is weighted random discard when the weight as defined in the ZIP goes over a certain threshold, and so yeah, that's elements of it are being updated. The ones related to fees are being updated as part of ZIP 317, and there's potentially some other changes that we may look at in terms of the interactions with between sapling and orchard, transaction size differences, and so on. But yeah, ZIP 401 is the place to look for that.
Yeah, we actually noticed that Zcashd wasn't quite implementing the spec as written, because it uses the estimate of the size of memory rather than the serialized size for transaction. But it doesn't make very much difference.
Yeah.
Understood. Yeah, my concern was only because we are planning to implement the ZIP 317, and if some party still wants to bloat up the mempool with transactions that don't get included, will that be an issue?
Well, that's part of the design of 401, is that, so part of the weighting of the transaction is, so the original 401 design was, because at the time, all the shielded transactions were designed around a fixed fee. And so the logic was that you look at it's effectively the fee, like the fee per size of the transaction, with a floor set at a certain point, and then the discard doesn't just discard the ones that pay the least fee. It discards randomly based on selection weighted on the amount of fee paid, but it can discard anything from the mempool, and that ensures that you can't have adversaries creating transactions that exercise pathological behavior to essentially force out other transactions that are in the mempool, preferentially to the adversary's ones. And instead, it just comes down to, if the adversary wants to occupy X% of the mempool, they have to create and maintain X% of those transactions in there. The way that the eviction works, an eviction list, like when something is evicted, Zcashd adds it to a cache, like a Bloom footer or something. I forget precisely what it uses. Essentially,
I think it's just an ordinary set.
I think it's, yeah. So essentially, whenever something gets evicted, we make sure we don't just immediately allow it to be re-added prior to the next block. I think it is just unilaterally cleared on blocks, though. With the logic being that, because it could be evicted or rejected for a variety of reasons, but it may still be a potentially valid transaction for the next block. So it's the sort of thing we just keep an eye on, the memory usage, which of course anyone can do with for their local node with the get mempool info and get raw mempool. Get mempool info is the main one. You can look at the metrics, the stats at that point in time for the mempool. And if you're using the Prometheus metrics data, that also tracks those same metrics are exposed via the Prometheus metrics endpoint. So you can track your mempool's usage and both the size of the transactions in it and what Zcash is tracking is the memory usage of those transactions in the mempool over time. So as usual, it's mostly just the sort of thing that we've got to keep an eye on. And if we start seeing problematic issues, then we can refine and adjust as we uncover them.
Thank you for that rundown, Strad. Do we have any other items to discuss? I guess not. So thank you everyone for attending today's call, and see you all again in 2 weeks.